Hi everyone, today I'd like to show you how AnalyseTool integrates with MCP and why I think it's such an important addition. With the built-in MCP server, AnalyseTool can expose your existing C# commands directly to AI applications like Claude or any other client that supports the Model Context Protocol. Let's see how it works. First, I'll enable the MCP server inside AnalyseTool. Once it's running, the next step is simply connecting Claude. In Claude settings, I only need to specify the port used by the AnalyseTool MCP server. That's it. Now let's launch Claude. As you can see, AnalyseTool is already connected. The first thing we can do is inspect the available tools. Claude can see all the commands that I've chosen to expose through MCP. This is important because not every command has to be available to AI. Inside AnalyseTool, every command can be marked as available or hidden from MCP. Claude also lets you control whether a command should always be allowed, require confirmation, or never be executed. So you have control from both sides. Now let's try a practical example. I want Claude to rename my sheet names based on a combination of existing parameters. This is exactly the same functionality that we previously used from a custom frontend. The only difference is that this time I'm interacting with it through natural language instead of clicking buttons. One thing worth mentioning is that I didn't have to rewrite these commands for AI. The C# implementation is exactly the same. Before exposing them through MCP, I only needed a single AI prompt. That prompt generated descriptions for all my commands, explaining what each command does, what input it expects, what it returns, and whether it modifies the Revit model. These descriptions allow AI clients like Claude to understand how and when each command should be used. So I didn't create AI-specific commands. I simply taught the AI how to use the commands that already existed. And because these descriptions are generated automatically, preparing an existing extension for AI takes very little effort. While Claude is working, I'd like to point out what I believe is the biggest advantage of this architecture. The commands themselves don't know whether they're being called from a web interface or from an AI assistant. They're simply reusable building blocks. You write a command once and you can reuse it everywhere. It can power a custom front end. It can be called directly from AnalyseTool. Or it can be exposed through MCP and used by Claude or any other AI that supports the protocol. Even better, every improvement automatically benefits every interface. If I fix a bug, improve a command, or add a new feature, it immediately becomes available everywhere. There's only one implementation to maintain. Depending on your workflow, you can choose whichever interface feels more natural. Some users prefer graphical interfaces, others prefer chatting with AI, and in many cases, combining both approaches makes even more sense. For example, you might use Claude to analyze your project, identify problems, and prepare recommendations. Then, instead of giving AI permission to modify your model directly, you can review the results and apply the changes yourself through the AnalyseTool interface. That gives you the speed of AI analysis while keeping full control over your Revit model. Now let's look at the result. Claude successfully collected all the required information. After that, it executed the command and updated the sheet names directly inside Revit. The result is not only useful for my current workflow. Because extensions can be stored in a shared location, other team members can use the same functionality without rebuilding it. This means one person can create an extension, and everyone with access to the extension folder can use it through their preferred workflow. Some users can use it through the front end. Others can use the same commands through AI with MCP. The functionality stays the same, only the way you interact with it changes. This is the main idea behind this architecture. Build once, use everywhere. Instead of creating separate implementations for every interface, we create reusable functionality once and expose it wherever it is needed. Thanks for watching.